So let's go ahead and see secure boot image in action. In this example on R1, we have a flash card that has 3 iOS images in it. So we're showing the images in the flash card, and we've got a 15.0, a 12.4, and a 12.3 image currently stored there. The one in red, the 12.4 image, is the one that we're actually using. That's the running image. So we pop over into configuration T mode, and we issue the secure boot image. And remember, once again, boys and girls, you need to be on the console line for this to work. So then it's going to go ahead, hopefully, and successfully activate the image resilience configuration. And we get the syslog message, just like the documentation said that we would, and successfully secured the running image. So then we pop out of configuration and we go and issue the show secure boot set, which is our verification command. In this case, we can see iOS image resilience, and remember prior we had iOS configuration resilience for the secure boot config. So this is logical. It shows the version 12.4. It shows when we went ahead and did this. It shows where the file is, flash c blah 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 blah, and we can see that that matches up with the file that we already had. So we've taken this image, the running image, and we've gone ahead and secured it. Type is image elf. Elf? Do we got little motherfuckers running around with pointed hats and messing up shit? Now this is a file system. I think it's executable and linking file system, but I'm not 100% sure. Basically, this is just how iOS is determining that this .bin file is an image. So now we go ahead and run our show flash include .bin just to see the images that are in our flash memory, and we see the 15.0 and the 12.3, but we no longer see the 12.4. And the reason that is because that's the image that's been secured. This feature hides this image, so if you do a dir or a show flash or whatever, it's not going to show up in there. And we'll retouch on this at the end of the presentation, I think on one of the last slides, about some of the possible caveats with this this feature. But you can see where this is going, that if you didn't know that this was enabled, you had no clue about this feature, you'd go in and you'd take a look for your running image, and it would appear that it wasn't there. This slide just reiterates that we no longer see our running image in flash. A couple of interesting bits here. So here's our running image. Again, it's highlighted in red, and we can see that it's part of the secure boot set now. What's interesting is that here's the image size, and of course the image size is the same as the one that's in the boot set. But this is kind of cool because here now again we're not going to see our running image in our flash memory. So even though it's not there, we kind of know that it's going to be there because of the amount of space it's being used. So prior to issuing the secure boot image command, we had, I'm not going to read off this number, this much space being used. Now we've got actually a little bit more, and trust my math on here, it's 4096 bytes more. So this image is still here, it's just hidden. And the cool thing is that 4096 bytes, that's minimal overhead. This feature is very, introduces very minimal overhead to accomplish the securing of the boot image. I've alluded to this a couple times already, that there are some quote-unquote gotchas with the secure boot image command, and the first of those is due to the fact that you cannot see this command in your persistent storage. So it's basically invisible. Not only is it invisible, as Cisco states here, the resilient configuration feature will deny any request to copy, modify, or delete the secure archive. And those characteristics lead us to the first gotcha here. It says, be careful when copying new images to persistent storage because the existing secure image name might conflict with the new image. And what that's talking about is that with the secured image being invisible, you can get an engineer on there and say, well, okay, we don't have an iOS on here. What's going on here? Let me go ahead and TFTP, FTP, whatever method you use to get the iOS image to your flash or persistent storage. And he starts that process, and because of the second bullet here, you can't copy, modify, or delete, it fails. And he's absolutely confused as to what's going on because he doesn't see the image and he can't update the image, upgrade the image, or add a new image on there. He can't upgrade the image. If he's trying to put the same image on there, then it's going to fail because you can't modify or delete this until you disable the secure boot image command. And Cisco helpfully says, go ahead and do the show secure boot set. But if you're ignorant of the existence of this command and or the fact that it's configured on your device, you're never going to think to to do the show secure boot set, or even be aware that that command exists. So I guess if you're going to implement this, go ahead and make sure that all your engineers are on board and know that you've implemented this. Maybe put it in your engineering diagram, or state it somewhere in your policies for your routers, because it can be very confusing. I mean, you don't see it. It's not there, but it is. Okay, and then the final quote-unquote gotcha. The feature can be disabled only through a console session, and I've harped on this ad nauseum that this is probably the biggest gotcha for the Cisco iOS resilient configuration, both for the boot image and the boot config, is that you need to have access to the console port on the router in order to do a lot of the upgrades and disabling of this feature. So in this case, it says it can be disabled only through a console session. So you can telnet to a router, implement the secure boot image command. It'll secure that image into the secure boot set. But now, in order to disable that, you're going to need to have console access. So it's kind of tricky there. You got to watch out for this and keep that in mind. Hopefully this will be the last time I harp on this. I've said it a bunch of times during this lesson, but it is a very important point to keep in mind. Alright, so we've reached the last slide, and of course the last slide is just going to go ahead and hammer home once again something that I've been warning you about throughout this entire lesson. So if you want to remove iOS resilient configuration, and that includes either the secure boot image or secure boot config command, there's a big limitation. And do you remember what it is? It's that you need to be able to log in via the console line in order to remove either the secure boot config or secure boot image commands. This is a big limitation, and you're probably sick of me telling you about it, but trust me, being aware of this is very important. So as you can see in these two examples, we've logged into R1 via telnet, and whenever we issue the no secure boot image or no secure boot config, we get the message you must be logged in. You must be logged on the console to apply this command, and you get a syslog message that says go fuck off. You're not going to be able to do this. You don't have access for this command. I probably should have touched on it in the last slide, but with the secure boot image, this gets to be a problem because you might have a flash card, quote unquote persistent storage device that has only enough storage for, say, a single image. So in that case, normally when you're upgrading iOS, you would use the overwrite command, or if you're feeling brave, you would delete the current running image and then push out the new image to your flash card. But in this case, if you don't have the space to add a second image, now you have to go in and issue the no secure boot image, and again from the console line to unsecure that image, because when it's secured, you're not going to be able to overwrite it or delete it or modify it anyway. That's what the feature does, and it's invisible, which again, we touched on that. It can be very confusing. So you'll have to do that and then go ahead and push out your new iOS image, whichever method you use. And I know I've harped on it a bunch of times, but it is very, very, very important to keep this in mind, that you will need console access to disable this feature. Unfortunately, you can go out to any router right now in your network if you have the privileges to get into configuration and issue the secure boot image or boot config. You'll enable it, but now in order to disable it, you do have to have access via the console line. So if you're planning to use this in your network, keep that in mind, because if you got, say, 600 remote sites and you push out a script that goes and turns on the secure boot image command, you've implemented that 600 sites, but now you better have a fucking way to get on the console line at those 600 sites, because at some point you're going to need to disable this, whether it's just for an iOS upgrade to free up space or whatever, whatever the reason is. So I know I've said this a billion times, but it's better to be annoyed by it and remember it than not to be aware of it. And that's actually going to end the theory portion of this. I'm actually going to break off the lab portion into a separate lesson. So I hope to see you over there. As always, I hope this is beneficial, and I hope to see you soon. Thank you. Goodbye.